Hello everyone, welcome back to Mr. Random Generator. Today I will be showing you how you can implement RSA algorithm using Node.js. Okay, so start off with we first need to create our project folder, so I just go ahead and create a folder RSA example, and we just open it up on Visual Studio Code. Okay, after we have opened it, we need to create our basic Node.js project, so I just hit npm init and pass the argument y, which automatically defaults it. Okay, so we just initialized our project. Now what we need to do is install a package called node-rsa, and to install it, we just type npm I or install node-rsa. Let that install, and also I will provide some really useful links in the description. Be sure to check them out, and the node-rsa npm page is one of them. So now we install that. We can just create a new file. Let's call it a generator. I will explain that in a minute. Generator.js, and okay, so this is the file where we create our keys, and to do that we just need to initialize and include a packet in our project. So we just type rsa equals require node rsa, and since I want my keys to be stored on files, I also need to include file system module, which enables us to make read and write operations in our file system. So we just include file system as well. And yeah, we also need to just, this is the correct way. So in our RSA algorithm, as you know, we have a public key and a private key. However, node-rsa module generates using a single method, then it actually generates both in a single method, then we export those. So to make things a little bit easier, I just create a function. It's called generate pair, which does not take any input, and let's say our key is key variable, and we just create new node rsa obviously not node rsa because we just named it the rsa, so yeah. And as you can see, it does have a method called generate key pair, so we call that. Now if we run that, we just made our keys, but we need to export them as well. So our public key as you can see, we have an export key function. So what that does is exports the key according to the specifications that we give it to it. So in our case, we just want our key to be, we just want to export public key from that. So we just type public, and you can again see variations in the npm page of the node-rsa module. And we just do the same thing with the private version. So we just private key and make that private. So now we have both of our keys. We want to write them in a file, and to write them on a file we need to again use the file system module. First we need to open our files, so we use OpenSync method, and in that method what we want to do is just give the path of our file and pass an argument which specifies the operation we wanted to do with it. So what I mean by that, let's say this is our directory, and this is the operation that we want to do. In our case, it should be write, so we give the argument w stands for write. And as for the fact, let's create a new folder and give it the name keys. And in this folder, we just want to create a new file, which is public.pem, which is the extension for generally keys. And we also wanted to create private.pem. You can also use key as an extension, by the way. But let's go with PM for the moment. So, to open those files, let's give the directory, as you can see, keys, and let's open the public one. So public, public.pem. So we just did that, and now we want to write the actual key to it. So we just call the function write file sync, which writes it obviously synchronous manner, and the thing we want to write, again, we also need to specify it on the here. So we just go at keys and public PM, and after that what we want to give is the actual key itself. So there you go. And finally, we need to mention the file encoding, which is UTF-8, just like so. And after we did that, we can just copy it again and just make the public ones private, and it should be working. So after that, we obviously need to call the function itself, so we just hit generate pair, and let's try it out, save it, and the public, obviously we need to change that as well, private key. Yeah, there we go. Now if we run node generator.js, it is running. It is running. It should be done. There we go. Now it's done, and let's check our files. As you can see, it successfully written the public key and the private key. This is how we generate and write our keys in a file. But if we want to use that, we need to do something more. So let's create another file. Let's call app.js, and we obviously need to import this stuff. And actually, let me see if we can copy. Yeah, we can copy those as well, but we don't want the export methods. Okay, let's go over one by one. So we import those, and we just, again, public key, and we just initialize them actually empty. We don't want to do anything right now because we want to import them from our files. The only reason I'm showing this is how you can import it and basically use in some applications, and I'll mention those applications in a second. So just private key, new RSA. We just created empty versions, and to read those, let's say we want to read the public key, we just use again our file system, and we now use read file sync. Just like the right one, we want to give the keys, and let's say again, yes, this is the public version, so public PM. And now what we want to do is give again the encoding, which is UTF-8. So yeah, duplicate it and make the same version with the private one. So private, this should be private as well. Okay, now we have read from the files. What we need to do is extract the key value from itself and put it in our key objects, which we mentioned right here. So to do that, we just, let's say, public key that it does have an import key function, and what we want to pass it in is the variable that we have read from the file. And we again want to do that with the import key with the private version as well. So yeah, private. So now we can use our keys, and like, to give an application idea, what you can do with that is basically create license keys. So it's obviously really simple version of license key, but we can just give it a go. So function create license. So we want to create a license, and as for the input, let's say we want our users to be inputting their mail address, so we just give it a mail. And let's say we want to basically make the reverse engineering a bit harder task for them. So what we want to do is create salt, which is fancy very word of saying like the random string. Let's say just make something along those lines. I don't even know. But you can use fancy password generators, etc. to use that. And again, we want to use another salt. Let's say salt second for a naming convention. Let's just copy that. Just change it a little bit. Okay, now we have created our salts. What we need to do is we just want to create the encrypted version of them. So we have const encrypted, yeah. To encrypt a message, what we want to do is use our private key. Private key, yeah. And we want to encrypt it using encrypted private method, because we want to encrypt the message, and then we want that message to be basically our license key, and we want our users to enter that to their application, and in that application we just want it to be decrypted by using the public key, so we can cross-check the message and we can say it is valid or not. If we want it the opposite way, each user must have a private key that we need to encrypt by using their each public key, which is not a wise choice because there are many public keys available for many users. Because of their, every user must have any private key, and those pairs are again like assuming that they have vast amount of them out there. Anyway, let's call encrypt private. And in this function, what we want to do is we want to give our salt first plus mail and plus salt second, and the encoding buffer, as you can see, which is the base 64. So this is the encrypted version, and we just return that. So let's try that. Create license. We just give like at example.com, save it, and run it. Node.js. Again, we obviously need to log it so we can see what's up with it. So console log. License. And there we go. We have just created the license. So to use it, what we need to do is create a function called check validity. So let's do that now. Function check validity. And this function takes our license as an argument. So and in this case, we want to first obtain the decrypted version and compare it with the original message. So we just create a variable called decrypted, and we should use public key that decrypts. And again, since we're going kind of the opposite way, we want to use the decrypt public method. And in that method, what we want to give is our license, and again the UTF-8, which should be our encoding. Yeah. So, and we just want to create a super basic if statement, like copy that, and we just insert a at example.com, and we just copy the second one, paste it right there, and if that is basically equal to the decrypted one, we can return true, and if not, we just return false. So let's try it out. So this is our license, so copy that, and we just want to run the check validity. So we just get check validity, just call it, and give our license as an argument, save it, and run it. And it's not working. Check validity, not validity. That is because I'm using a different keyboard, not my super loud mechanic keyboard with blue switches. It is too, as you can see, now we run it, it basically returns the true, so we can see that it is valid. So I know these concepts are not that very simple to grasp on, but I'm sure you will get it in a reasonable amount of time. So hope you like this tutorial. If so, please be sure to hit like button, and if you want to see more content like this, please consider subscribing. Thank you, take care, see you next time.